Welcome to Music 320, Week 13, Lesson 1, where we'll be introducing jitter and looking at the JIT matrix structure. So this is really the last topic we'll be covering in the course. And this introduces the whole world of video in Max MSP. And that the video processing world is called jitter. And you'll notice that all of the objects that are used in the video processing world will have the prefix JIT. So they will be JIT.matrix, JIT.window, JIT.pwindow, JIT.whatever. So in the same way that your signal objects had a tilde at the end to signify that they were signal objects, jitter objects have a JIT at the beginning of them to signify that they deal with video images. Video processing. So what can you do with jitter? Well, you can play videos, but not only can you play videos, you can take the data out of a video, you can process that data, and then you can project it or put it into another window. You can have sound controlling the way that video is being processed. You can mix videos, you can change the color attributes of videos, and really a pretty wide range of things that you can do with jitter. So let's start by looking at the JIT.matrix structure. Now we've looked at signal objects which pass signals from one to another, which is a continuous stream of floating point numbers. We also had floats and ints and lists and bangs and other data types. And the matrix, the JIT.matrix, or let's just call it the jitter matrix, is a different data type. And it's a data type that's capable of passing video information from one object to another. Now, when you look at the signal objects, you notice that they all have a yellow and black patch cord when you connect them. You'll see that when we deal with video images, or video data, that we have a green and black patch cord that connects the object. So you can tell that this is a jitter object that is passing video data from one component to another, just by the appearance of it. So what is video data? Well, essentially the jitter matrix structure is a three-dimensional array of data. So if you can imagine that a normal array, a single dimension array is just a series of numbers like a table, and that a two-dimensional array would be a series of tables or a sort of an XY grid that would allow you to create, let's like this, a series of data could be stored in each one of these components. A three-dimensional array is a series of these two-dimensional arrays that can be used to store data. It turns out that video images and even any kind of graphic image needs 4 planes of data. So the way these matrices work is that the 4 planes of data store information on the alpha channel, the red channel, the green channel, and the blue channel of a video. And that each plane contains dimensions which represent each pixel of the video. So in this example, I have a jitter matrix that is 4 planes, each of which is 4 by 4. So this allows me to represent 4 pixels of alpha, red, green, and blue. So these, and we need all of these in order to render or to represent a 4 by 4, a tiny window of video. So just to make that clear, we have 4 by 4 grid, which think of this as representing a very tiny corner of a video. And then we have 4 planes so that we can store information on the color of each of the pixels. Now the alpha channel is a transparency channel, and this doesn't make a big difference to most uses. The only time the alpha channel really is used is if you have multiple videos and you want to control how much the video in the background shows through the video in the foreground. So under normal situations, you don't have to worry too much about the alpha channel, but think of this as a range of values between absolutely transparent to being totally opaque. Now the range of values that's in each of these planes, they're all between 0 and 255. It's data that's stored in a single byte. And those of you who have done a lot of work with graphics program will be familiar with representing color as red, green, and blue, and possibly even with an alpha channel. So here in Max, we have alpha first, then red, then green, then blue. We need all of those in order to represent the pixel in any possible color. So I should mention that in a jitter matrix, it's also possible to use values between 0 and 1.0 as floating point numbers, but for now we'll just imagine that they're all single bytes between 0 and 255. So if we can imagine taking this pixel and representing it as a single color, we need an alpha value. So let's take 255, 255, 0, and 0. And this would give us red. So the pixel would appear red. Then if we took the next one beside it and we made it 255, 0, 255, and 200, it would appear this color. And then the one beside it will make 255, 128, 0, and 255, and it would be this color. So when you have a real video, you will have a much larger array than we have here. Here we have 4 by 4 by 4. That gives us 64 values in total. If we have a video, let's say that is 320 pixels wide by 240 pixels high, then we have a much, much larger array of data. So if we put in 320 times 240 times 4, we have 307,200 pieces of data in that matrix. Okay, so a lot of data is being passed down this, and those all that data basically is needed in order to render or to display or process one frame of video. So when a video is running, constantly updating, each frame of the video becomes another 300,000 values that are being passed down and being rendered. So there's a lot of data being passed down in the jitter world. Okay, so I'm going to bring up the jitter matrix help file, and I'm going to make it a little bigger so we can see it a little bit more easily. And we're just going to look at basically an example of the jitter matrix. And I'm spending a lot of time on the jitter matrix, but this is the data that's being passed around in all of these objects. So you can see here we've got a dimension of 5 by 5. Let's make it 4 by 4, just so we're doing exactly the same thing we already did. And this particular, and the plane count is 4 because we want alpha, red, green, and blue. We want to be able to represent all those colors. And the type is a character. That's a single byte, so 0 to 255. And what we have then is a matrix where we have, you think of them as cells, from 0, 0, 1, 0, 2, 0, 3, 0, 0, 1, 1, 1, and so on, all the way down here to 3, 3. It's just a coordinate system. And so we can, we can actually set cells and pass values into them. So we're at 0, 0, and let's just say, all right, what happens if we have 255 there and 255 here? You see the red, and let's put a little bit of green. Let's put 16 green and 100 blue. Right? And we get this sort of pinky purple color. Now you notice that the output of the matrix is one of those green cables that I mentioned. And it goes into this, is called a JIT cell block, which allows us to actually look at the data in a jitter matrix. And we can look at different planes. So we can see that the 0 plane, i.e. the alpha plane, is 255, the 1 plane is 255, the 2 plane is 16, and the 3 plane is 100, which are the values we put in. I'm going to take out this clear button. I don't like it. And let's go to cell 1, and let's put a different color in there. Let's make it purple. And let's go to cell 2, and let's put a different color in there. There we go. And let's go to cell 3 and put a different color in there. All right. So we have the, I'm making a video here. I'm making a picture, one cell at a time, by simply going in and putting the values in there. And you can see how you need the alpha channel. Well, you don't really need the alpha channel here, but we need the R, the G, and the B. We need all of those in order to represent a color. If we don't have the G and the B, then everything will be it'll be red of some intensity. Okay. So for example, if we go back here, I'm going to make, let's actually make this one 0 and 0 and 0. Notice that it's black. If I make it 255, 255, and 255, it becomes white. So when RGB is 0, we have black. When RGB is 255, we have white. And then any combination. Those of you who've played with this before will know, like 128, 128, 128 will give you a gray color, and so on. Right? So that's basically the matrix object in a nutshell. It can be used for generating video, but more often for taking video out of a video player and then manipulating